Um, so we already had an introduction about me, right? So I'm not only an academic, but I also do buildings. But there is a kind of overlap between my work in generative systems and in designing buildings. And this is kind of captured under having a design studio, which is called Adventurous Architecture, but also a company that does digital systems for AEC, which is called Adventurous Systems. But I'm also a founding member of ArchiDAO, which we will take a look into its workings throughout this talk. ArchiDAO is essentially the first architecture decentralized autonomous organization, so the first organization that deals with architecture and running on blockchain. And I'll start with a kind of story on Greek mythology. You probably have heard of Ulysses or Odysseus. This is a kind of epic poem written by Homer, written about 800 BC, and describes essentially the travels of Odysseus after the Trojan War, where for 10 years he kind of roams the Mediterranean Sea, attempting to return home. And when he returns home, because 10 years have passed and he's kind of unrecognizable, he has to kind of reestablish his identity to his home, but also to his wife, who actually says, welcomes him and says, if you want to sleep here, you will need to take the bed and sleep outside. And that's a trick question, actually, because Odysseus immediately responds that this is impossible because he himself had created the bed and the whole room, the whole marital room and the whole palace around that bed by essentially taking a tree and without uprooting it, cutting the tree and shaping the bed around the roots of the tree. So the whole bed is kind of shaped as an object around the roots, and it's kind of embedded in the earth. And around that, you have essentially the marital room and his whole palace. And what we have is essentially Penelope, his wife, using a cryptographic cipher to recognize or test whether Ulysses is himself, right? So she tests his identity, but also at the same time, the story serves as a kind of facsimile for architecture. Essentially, architecture is a way to intervene into the world, and it's taking materials and transforming them into something else. And a lot of the kind of stories and mode of architecture has been shaped out of these kind of understandings of taking natural resources, being extracted from the environment and transforming it into something else. But then I'll take you a little bit onto a much more, let's say, collective understanding of architecture and the crypto semantics of signing a work of art, right? We saw essentially Ulysses having kept secret his signature of the transformation of the bed and the room out of the tree. And I'll take you to a small book called Shanzhai, Deconstruction in Chinese, written by a Korean-German philosopher called Byung-Chul Han, who essentially breaks down for us the understanding of how Chinese culture creates this wonderful remixes of modern ideas, where you might get essentially through production of cheap objects, combinations like Obama with Coca-Cola or similar, right? And he talks about this idea of Shanzhai, which is literally means bandits on the mountain. So kind of like this idea of producing things out of pirated content. But there is a kind of deep-rooted understanding of this within the jade seals that Chinese literati and officials would use, right? So these are, jade is very valuable in China and almost only in China, right? If you try to buy it outside China, it won't be that expensive. And out of this jade rock, you can form essentially the signature, the sign essentially of the official. And within Chinese understandings, the seal is the person is the seal, right? So that's why, for example, you never allow anyone else to have access to your seal because they can sign documents as you. And within the book, a Chinese scroll is presented, so a work of art that is given as a gift to one of the officials, which is now posted in another place. And his friends actually write a series of poems and then sign it. Each one of them signs it. And with each signature, this work becomes a collective work of art and changes essentially how it is created and its nature. And we have now a kind of different form of creativity where we take a work of art that is already created and present, and we change it and we adapt it to a new condition, essentially. So these Chinese officials essentially give a collective, a beautiful work of art that also includes their own thoughts to their friend as a farewell present. So I want you to hold these two ideas together, right? So on one hand, the idea of architecture as a manner of changing natural resources into something useful, and the other idea of taking something that already exists, has already been created, and transforming it into something else, even just with the idea of signing it, which we will see plays a major role in blockchain and Web3. And I will refer also towards this idea of regenerative architecture in this small volume created by the collective space Caviar, which is called non-extractive architecture. It was presented in, I think 3 years ago in the Venice Biennale, on how we could change our production systems on designing without depletion, right? So could we make architecture being non-extractive towards nature, being non-extractive towards the economy, and so on and so forth. And the work, my work on Web3 and blockchain relates around the architecture and economy, but also governance and architecture, right? So if you think about a governance, this is essentially how you make decisions about things, and how do you do it in a way that is collective rather than singular. And I'll take us almost 30 years ago to this any symposium where a lot of the star architects were present, and Bernard Tschumi kind of recognizes that the economic and political powers that make our cities and our architects are enormous. We cannot block them, but then we can use another tactic, which I call the tactic of judo, that is to use the forces of one's opponent in order to defeat it and transform it into something else. And to what extent can we move away from a descriptive critical mode to a progressive transformative mode for architecture? And I think the same question kind of applies today. To me, is talking about capitalism. And there is a kind of understanding, at least back then, that architecture was essentially subservient in serving a lot of capitalistic notions of production, essentially, while some of the star architects were also trying to kind of change the discipline, but also change society through that kind of idea. And there's always the question of should we actually engage, in a political and economic kind of discussion when we're dealing with architecture, or should we just, do our job as architects and create buildings without actually challenging the economic and political regime or status quo within what we're operating in. But at the same time, we have a massive problem, right? We need to house an ever-increasing population, and our activities at the same time account for a massive 39% of all carbon emissions, right? So we have essentially a massive conflict between our goal to provide shelter for everyone, but at the same time, the effects of providing that shelter have consequences in terms of the operational carbon equivalent and the embodied carbon equivalent that we're producing. And what we're trying to see is the industry, the whole industry to which architecture belongs, right? So we belong to a larger industrial conglomerate called the architecture, engineering, construction. You might also hear it as architecture, engineering, construction operations industry, which is a really fragmented industry. We don't have super companies operating there. Almost everyone is an SME. They're all small companies. It's actually unproductive. So you compare the performance of AEC industry compared to, say, the automotive industry or the aircraft manufacturing industry or manufacturing in general, you will see that our productiveness has increased globally by about 1% the last 40 years. So a negligible kind of improvement. Whereas manufacturing has increased to about 20% year over year. So a massive kind of increase on that level. And at the same time, in most countries, the AC industry is adversarial, right? So you enter into a contract and you are always afraid of not getting sued essentially by anybody else on the same kind of project. So a lot of the relationships that built up within those kind of ideas are not, let's say, conducive to collaboration, but rather you try to do a job very much alone and without actually serving a really good collaboration. So I'll take a little bit into the rabbit hole, right? So most of you probably are familiar with blockchain. Most of the concepts I'll present today discuss the Ethereum blockchain. This is the one we have worked for mostly in our prototypes, mainly because it had the best tooling in terms of developer tools. A blockchain is essentially a decentralized network. It's a very simple concept. You have a network of computers that have no central authority to coordinate them. But essentially, every computer is running the same ledger. So they have a copy of the same ledger. And within that, they record transactions. The most simple of transactions might be, buying a coffee. So we remove 5 Swiss francs from my account and we give them to the coffee machine, to the account of the coffee machine. And essentially, all of the nodes actually update their ledger according to that single transaction, right? Which raises the problem of how do you coordinate that network without a central authority. And essentially, this happens through a mining coordination. In the original Bitcoin, this is a Bitcoin kind of definition, which is kind of like the first real blockchain people created by Satoshi Nakamoto. You have essentially a series of transactions cryptographically collapsing into a Merkle tree. This is what you see on the center, on the lower part of the image. So the transactions that happen at every point get hashed cryptographically and then hashed between them, resulting essentially, as you do it in pairs, into one cryptographic hash, which along with the number used only once or a nonce and a timestamp are included into a block. And the hash of that block is included into the next block, hence creating a chain of blocks, hence a blockchain. And deciding which transactions are actually going into the block is run through an algorithmic competition. There are many ways to see this, right? The proof of work which Bitcoin uses is very energy expensive. There are other competitions like proof of stake or proof of authority. So I won't go too much into the algorithmic part of how this is taking place. What you see now in the screen is a definition of the ETH hash proof of work competition that Ethereum was running before it transitioned into proof of stake. And here, every node is running essentially a cryptographic algorithm, producing one number, which is then compared with a pre-selected target. And the one that is matching actually gets elected to be rewarded with more cryptocurrency from the network itself. So you get an award essentially for helping to define the next transactions and secure the network. And it's very easy to actually understand blockchain as a computer that does addition and subtractions. But if you do addition and subtractions, you can also do multiplication and division, so you can do any kind of mathematics. And if you can do mathematics, then you can run software. And that's how we end up with the idea of smart contracts, which is essentially software that runs on the distributed, decentralized computer called blockchain, or the Ethereum blockchain. And this gives us the idea that we can run essentially software that is deterministic. We know that it will behave exactly the same way every time. And it is autonomous in the sense that it doesn't require a human to intervene so that it executes itself. And here you see essentially a rendition of both smart contract transactions, but also normal transactions taking place into an Ethereum, actually the Ethereum blockchain 7 or 8 years ago. I think that's 7 years ago. I won't go too much into the computing part, but essentially Ethereum virtual machines are Turing complete. So essentially we don't know whether computation will terminate. So we need an external trigger, hence we introduce the concept of gas, and gas pays for computation execution, right? So at the phase of an impossible computation, literally the process will run out of gas. But also it means that you cannot do things without actually paying anything on the blockchain. Every action incurs a cost, and you need to consider that when you're designing blockchain systems. Again, we discussed smart contracts, right? These are software that executes on the Ethereum blockchain automatically. Typically, there are classes of code run on the Ethereum virtual machine, which is the virtual machine that virtual computing machine that Ethereum nodes run. And from a programmatic perspective, right? So if you think as a software engineer, these are digital protocols intended to facilitate, verify, and enforce the performance of a contract, right? Credible transactions without intermediaries or third-party guarantees, right? So we are not using essentially a court or a state authority or any other kind of authority to conduct agreements and transactions through smart contracts. And if you have looked a little bit more into how blockchains operate, right, we have also the idea that on smart contracts, we can have certain designs of economic utility, right? We can create tokens. We can create non-fungible tokens, which is like the jewel you see on the left. And that is essentially a unique digital creation, which is cryptographically signed, exactly like the one we had from the Chinese literati, and is a unique entity, right? So no other entity has the same signature in the same network, in the same smart contract anywhere else. And within that, we might ascribe to it different values depending on what this creation is. Is it a jewel? It might be a building component, as we'll see later, or it might be other unique identities that we want to essentially store. Or you might have fungible tokens, which are essentially interchangeable, right? So the word fungible means that it is interchangeable with the same object. You've all used fungible tokens in your life. Every time you use cash, or so every time you have, 5 Swiss francs and you change them with another 5 Swiss francs. Literally, there is no notional difference between the two. I mean, there are maybe physical differences between two pieces of money, right? But at the same time, they hold the same value, or we all agree they hold the same value. So we can design essentially tokens that could be used with particular utility in blockchain. Here I present the idea of a game token that you can take to a game arcade, and you can essentially use it to play a game, right? And gain some kind of happiness and entertainment out of playing the game. And we kind of presented a little bit the idea of AC and where the situation lies, but why is blockchain kind of good fit for AC, right? I might hear you ask. And this goes back to the idea of governance, right? So we have essentially a very good fit between the AC industry being very fragmented, very decentralized, and the idea that blockchain allows for decentralized governance. And if we bring the two together, we can essentially look into the promise of blockchain for the construction industry. This is a chapter written by Jens Hohenwitz, who is a ETH graduate. And within that chapter, we kind of discussed why blockchain is a good fit for AC, but also how the decentralization that blockchain has can enable better governance within the AC space and architecture. And essentially, the proposal here is that we can go into creating more decentralized autonomous organizations, right? So organizations that use smart contracts to make decisions, record decisions, and advance essentially the state of the art forward. Within that kind of idea, I will also introduce Elinor Ostrom, who is or was a Nobel laureate, and she won the Nobel Prize for Economics for her work on understanding essentially the commons. And by doing field work, she kind of created this 8 design principles for managing the commons, right? And these are that commons need to have a clear defined boundaries, rules should fit local circumstances, participatory decision making is vital, commons must be monitored, sanctions for those who abuse the commons should be graduated, conflict resolution should be easily accessible, and commons could need the right to self-organize, right? And commons work best when nested within larger networks. And we'll look into the principles again when we talk about the workshop at the end. But the main idea here is that blockchain networks are essentially a common pool of resources, and their basic economic understanding is governed by these rules. So anytime a node kind of participates here, it is governed by these kind of principles, essentially. And there is so Jens Hohenwitz and Daniel Hall have written a lot about this. So I'll refer you to their chapters and journal papers on how this kind of applies also to the AC industry in particular circumstances. And when we're introducing blockchain and cryptoeconomics, right, we are essentially discussing about economic incentives and disincentives, right, going back to Ostrom principles. But we're also sifting trust to the computer protocol, right? We're no longer governing anything with legal contracts or human relationships. And we are also obviously talking about open networks and decentralized networks where there is no barrier to participation. So nobody needs to approve you for taking part into a blockchain network or a network that serves the AC industry. And that's a very long-winded kind of introduction. I'll go back to now presenting a little bit more on what work we've done on this, right? So some prototypes in a kind of fast pace understanding. Our work started in 2017 with design for a blockchain city. We participated in a competition for a futuristic city in China. And back then, the Chinese Communist Party was essentially still using urbanization as a growth engine and creating new cities every year. And as part of that, they created a competition. these new cities normally have some kind of flavor or theme, right? So there might be production cities, and this particular one was a big data and blockchain city, as they advertised it. And one of the things they did is they had a kind of modernistic master plan where you would have separate areas. So you have the entertainment area, the housing area, and also a big data warehouse at the edge of the city. And what we did is we designed an algorithm that would generate the city automatically, but also would embed within all of these densities that you see there, blockchain nodes within the buildings, so that we did not have a completely zoned understanding of where all of the computing nodes go, but the computing nodes would be spread around the city, in the understanding back then that we would use the extra heat produced by the proof of work algorithm to heat part of the buildings. And our conceptual understanding was lucky enough to receive the third award. And that kind of brought us into the idea that we could look a little bit more into blockchain as a technology that we could connect, say, to generative systems and algorithmic software, such as the one used by Rhino and Grasshopper. So we started to look into this. We started to look into how we could connect blockchain as a database for building information modeling, right? So how could we substitute the idea of a structured database behind a BIM software with blockchain? And we kind of identified 4 levels of integration, right? So we can have a blockchain running within CAAD, and then you have a second and third level where through the web, a CAD station can interact with a blockchain, or you can interact with the blockchain directly through an Ethereum node. And having the final 4th level, which is running a computer-aided design software on top of a blockchain network, completely decentralized. And then we started looking a little bit more carefully on how we could take architectural design and really decentralize it, really use the idea of smart contracts as a coordination and governance mechanism. So we started looking into a design optimization prototype that would use blockchain on the background. You see here kind of a conceptual understanding of how a DAO could use a BIM and blockchain integration to govern, design, construct, and operate an asset. And we kind of created a set of smart contracts. This is our first prototype where we have essentially a DAO which is trying to solve a design problem, which is posed by a client, and you use a set of smart contracts to do that. On the background, you use decentralized storage. So this is called IPFS, so the Interplanetary File System, where a file is not recognizable by its address, but by its content. So anything that you put there has a unique hash that is content addressable. So we're not asking the question of where something is stored, but what is stored. And from that point of view, you avoid repetition, right? Now, I won't go too much into the architecture of the smart contracts. There are 5 of them. One is doing the job of connecting with the BIM platform, and the others are handling the problem, the solution, and also keeping track of the storage behind the scenes. And the main idea here is that we were able to create essentially an integration between Grasshopper, Ethereum blockchain, and IPFS through Grasshopper. But also through the web app, we can also connect other apps like Dynamo and Revit, AutoCAD if you really needed to do so, and Topologic, which we use a lot as well. I'll run a little bit through the whole idea, right? So this is a blockchain running on my computer. We have essentially 10 available accounts, 10 private keys. So it's a test blockchain to test the concept. Here we launch all of the contracts onto the chain, and you have also IPFS running. That's the kind of web interface of what we have, where one can pose a design problem and then use this web interface to kind of solve it. The next step is to provide essentially, register as a solutions provider, as a problem optimizer, and then you can synchronize with the blockchain through the web interface, but also to see what is the kind of file that defines your problem, right? And all of this actually happens automatically. You don't have a server, anything, everything kind of coordinates through the blockchain, along, of course, with someone getting paid for solving it. This is a very old prototype, by the way, right? So that's 5 years old. And essentially here you see the result of sending a solution to the web interface and then getting paid. We actually wrote a Grasshopper plugin that connects Grasshopper to the Ethereum blockchain. And that's essentially the kind of interface, right? So you have an address, a key, and the value, which is the optimized value you send as a transaction. So essentially, when you synchronize, you download a Grasshopper definition, which you need to solve. And as soon as you find a better answer, you can provide this to the network. And then depending on how the problem is set up, you can either get share part of the profit or get all of the profit yourself. I'll go a little bit faster. So we have essentially two modes, right? One is a collaboration mode where everybody participating in solving the problem can share part of the revenue, or we can have a competitive kind of idea where all design agents can provide, only one gets paid when they provide the best optimized value after a certain time has passed. The other thing we're doing here is that we're also not making any kind of distinction between a design agent that is a human or a design agent that is an AI or an algorithm. So you could actually design an algorithm to try and solve this, and you might make some money while you're having your latte and not doing any work. And this kind of shows how the system works, right? So all of the designers are working towards a solution. They find an inflection point, which they contribute. The system notes the designer 2 contribution. Then designer 3 actually also makes some advancement, and then the system notes their contribution as well. And then the funds are shared between designers 2 and 3. So that's collaborative mode. Whereas here, every time someone finds a better solution, we have designer 2 and 3 getting paid every time there is an optimized understanding. And that's more of a general diagram where we understand the blockchain as a kind of infrastructure where you can note design solutions. And then as soon as there is a new design inflection point that kind of changes, either advances our understanding or changes the way we will treat a particular design, you can synchronize with other people around the world that are also trying to solve the same problem. And now I'll launch into a couple of more kind of theoretical concepts, which we haven't yet created into prototypes, or we have created like only very early prototypes on this, right? So one is how you could run decentralized building information modeling onto a blockchain. And this would require you essentially to only record the deltas, so the differences of what you're changing onto a file, which is kind of public. And the idea here is that we have kind of designed how you could have an infrastructure that is, publicly available. Someone can put a bin file onto it, and then a kind of swarm of designers could edit and advance the state of the art, while the system notably records every change and can reward, or we can set up reward systems around how they change the file. Again, I'm going a little bit forward. These are old ideas or old prototypes. But we also have new business models for architects, which potentially is interesting to you, where so far we have no way to actually get paid for digital files that we would release onto the internet, right? But we could actually now create our first non-fungible tokens where we could actually launch a BIM model that has unique solutions. For example, you could do a family of a Revit, a Revit family, for example, for a facade. And theoretically, you could set it up in a way that you could release it onto a blockchain, and anybody who would then use it on their BIM models, again, if they're hosted decentralized manner, you would get paid every time your model gets used. But also, if you contribute any kind of intellectual power into changing one of the models that is available out there, you would still also be included into the list of people who needs to get paid. So from that point of view, we can set up mechanisms where there are incentives for collaboration, there are incentives for improving upon other people's ideas. And this gets recorded essentially and also governed collectively, if you will. We then kind of created a decentralized autonomous organization using shape grammars. Shape grammars are basically a deterministic generative system where you have a dictionary of shapes and a dictionary of rules. Then you apply these to create a design output. And in this kind of idea, we are creating apartment floor plans in Suzhou, China, using particular grammars. We're testing them using the local regulation for sun incidents. And then there is a kind of voting that takes place through the DAO that decides which of the solutions to actually take forward for development. And again, we're using the grammars only so that we create, structural alternatives. You could have any other kind of way of creating design solutions into this. And another example we're still working on that I think has a lot of potential for circular economy is the idea that you can use, you can analyze a building topologically, you can analyze it into its mathematical topological constructs. Within this particular example, we're using the topologic Python library, which is created by my good friend and collaborator, Rasim Jabi. And you can understand that every particular space and every particular component actually can be made into, can be recorded into a smart contract as a token. And from that point of view, you could have, for example, as you see the room that I have on the left corner, you could have one NFT for the room and then 12 NFTs for the structural components, including 8 beams and 4 columns. And we showed how, we demonstrated how this would work. We can essentially tokenize any kind of asset in the building. We use topologic either in Blender or on Revit and Dynamo. And from that point of view, we are able, and here it is running on Dynamo, right, with a really simple building where you can essentially track and trace and create tokens out of any kind of building component. So the idea here is that a token is not always just a JPEG, right? But we could actually put it into the structure of a building information model. And if then we store models like that, we can trace them. We can actually, that data storage is going to persistent 30 years down the line. But also we can start investing now into the circular economy potential of buildings 30 years down the line. The smart contract is fairly simple, I would say. We're using the Open Zeppelin computational libraries. And that's how it works essentially on a really simple basis, right? On the smart contract, you have the NFT registry that numbers the tokens. And on the interplanetary file system, you have the hash. This is what starts with QM of each building component, right? And I could upload that using an open format. And our prototype works with topologic, any kind of visual programming interface, right? So you could have it running on Grasshopper, on Zwerchok, on Blender or Revit. you have obviously a geometry platform, right? So Rhino, Rhino, Revit, and so on and so forth. And then Python is used as the kind of glue that puts everything together and creates our basic infrastructure for a circular economy. And that's how it would work essentially in terms of commanding, right? So you send any kind of information from your visual programming kind of interface to Python. You don't interact with TopoloGic directly, but it runs on the background on that sense. Here, proofs of how it works on the blockchain interfaces. And this is in one of our workshops on how we run it on Blender. I'll take a pause here to see if there are any questions before I move on, and I'm about to close with one or two more projects. Are there any questions so far?
Not yet.
Not yet. Okay.
I don't
so, sorry, go on.
Hello, can you hear me?
Yes.
I just want to check if I understand correctly, like the way how do you, because like the blockchain or everything for us, for me personally, it's very new. It's very abstract. But so far, in my understanding, like the way how do you try to explain how do you practice with this DAO with the blockchains, like on one side it influences the finance aspect. On the other hand, it also in the like topological, it can also, you are supposed to try to figure out a kind of a guideline, a regulation to make sure that it's the geometry of the architecture, it could be related to the blockchain. Do I understand correctly?
Correct, absolutely. So we are not only using the economic understanding of blockchain as a means, but also we are using its computational power and its persistence, because essentially we expect that blockchain networks will exist in their current formulation for a very long time. So essentially we're using them as a kind of decentralized storage and decentralized computation platform that we can do interesting things with them. Hence why the application of circular economy, right? And the application of analyzing a building in topologic format. But also a little bit more. So a lot of it is theoretical because we had to, I mean, when we started working with this, there was nothing in terms of the theoretical understanding. And I'll explain now a little bit more what you can do more practically on this level. So we, back in 2020, we made a call for chapters, and we created a book. We wrote with my colleague Davide Lombardi 3 of the chapters, and I'm going to present essentially the last one, which is called Collective Digital Factories for Buildings. And the idea here is that we're trying to handle through the blockchain, optimize essentially carbon, waste, productivity, and supply chains. And again, the idea here is that you have a pool of funds that you see on the top, and you have a design team that decides essentially to engage with the design problem. They stake, so they are able to actually provide a token, probably money, and in exchange for that, they are given a governance token, which allows them to make decisions. And through that, we are then able also to, so that's what it described here. And any one of you could actually participate in this kind of idea. You could actually participate in this governance pool by being one member of the design team. But also imagine that the tokens staked are against the funds that are going to fund the project, right? So you have essentially a financial stake on the project. But also, and this is where it becomes interesting, we can use essentially smart contracts to keep track of improvements in the design in a transparent manner, right? So we can actually set targets in terms of carbon, energy, the waste produced by a particular design, or whether a design is circular or not. And through essentially topologic as a library, we can produce interesting iterations until we have the final design model, which is then gets measured and gets recorded onto a smart contract. And this essentially can go back into setting targets for productivity, waste reduction, carbon reduction. And if we set correctly the way the common pool works, the funds, you are then incentivized to reduce carbon, reduce waste, and increase productivity, and you will get paid more if you do so. So we can set essentially the smart contracts onto a way where by you being economical, right, you get more money as an architect in a sense. And the idea here is that you can create a digital factory, right? So this is what the design team and the smart contracts are, where we can create essentially a framework where design is actually used and regulated essentially in a much more collective manner, with goals that are not always financial, right? So we can express essentially targets that are more societal and embed them essentially into the design process like this. These all gave the idea to actually start the first DAO, and we started by looking at the theoretical kind of underpinnings. We wanted to look if there is a way to use smart contracts for collective authorship. So we looked into CAAD. The chair that this course is part of, right, has a lot of papers on CAAD, if I'm not mistaken. And I think you can access all of it if needed. And we were looking at essentially 8 principles, 8 questions, right? So communication between design members and the object, are there the existence of feedback loops? And we asked also in this kind of collective authorship question, how decentralized the system is, and is there the idea of a substrate? And there was a clear gap there that in terms of decentralization and substrate, right? So where exactly do people record decisions? And this takes us back into also a governance model that is very decentralized. It's called the viable system model. And that was the underlying model for CyberSyn, a kind of digital system to govern Allende's Chile, where edge nodes like work units can make decisions autonomously while still serving the overall purpose and cohesion of the organization, right? And this is where you share essentially intelligence and policy for each one of the decentralized work units. The kind of most common example you can find on this is the idea of stigmergy, where again, the idea of a signature, stigma in Greece, and the idea of production, right, work, has been used by biologists to explain the way bees create their hives or termites create these mounds, where essentially the ants and the insects essentially collaborate without a central mechanism for decision making, but they have essentially a common incentive. They trust each other, and they are also operating within a kind of common pool resources idea. And from that point of view, we wanted essentially the DAO, the ArchiDAO, to follow these kind of principles of stigmergy, of being productive, of being trustful, and of having incentives that help people grow. I have to say we were really good in theory, but not so good in practice. And we're now finding ourselves in kind of reinventing the organization. So this is the what we were writing back in 2021 in terms of the, sorry, in 2022, sorry, yeah, on how these principles would work using smart contracts. We would have a non-fungible token that would create identification for every member of the DAO. and then various contracts that would record essentially productive relationships for every project. We created even ways where we could have projects decentralized, assigned to the DAO, and then the DAO would work out. Members of the DAO would work on the project and get paid for it. I'll kind of skip crypto twin, right? So we have an architecture for creating digital twins using blockchain, and I'll go into crypto bridge. So that's an architecture competition where we needed to design a bridge in the south part of Sofia in Bulgaria. And we started looking into the idea of placing essentially some of the earlier ideas we had about NFTs into the design of the bridge. The competition was calling essentially for connecting these two pieces of a park, and also providing an identity, and so on and so forth. So we kind of designed this spine through the park that emerged out of the nodes that you see on the left. And we also designed the bridge so that it's made out of pieces that could then get recorded on the blockchain. And we could use crowdfunding principles to have people decide on the design, the funding, so they could actually claim ownership of part of the bridge, but also have a claim onto the governance of how the bridge would operate and be maintained later. And here we have the idea that we kind of create a design that is initially full and centrally made, but then is broken down into pieces, into these discrete elements that can be essentially recorded on the blockchain. And there are many ways to do this, right? You can see some examples here. And these could be adopted essentially by people on a crowdfunding basis. And we also created these folies, again, by assembling discrete elements that could then also be adopted, where you could, choose the color, choose the material, and pay for it and help fund the project. Unfortunately, we didn't win, but we still have the ambition of actually finding a public project where we could actually introduce this idea of a mix between bottom-up decision making, and then the architect also playing the role of the orchestrator, with the blockchain kind of taking part of the orchestrating the decision making approach. And I'll now go launch into our latest project in ArchiDAO. This was also presented as a paper in NICAD in Cyprus. And the idea here, sorry about the problem in the presentation. Let me try and see why this is. So we're looking essentially to create a first 3D network that orchestrates additive manufacturing all over the world by using blockchain technologies. And the idea here is that you have a very complex mechanism in the production of 3D printed structures. You need fine-tuned knowledge and expertise. But also there is a dual problem, in the sense that a lot of the practices that go into 3D printing have not been scientifically validated yet, which is something we have a problem with. And we know this by this example. So one of our members is Heriot Watt from Czech Republic, where he created the first 3D printed structure in the Czech Republic. And one of the problems they had is that they could not pass the regulatory approach check from the permit office, the official authorities, because they could not prove beyond dispute any performance targets that the 3D printed concrete would achieve. So we think there is a big potential in using essentially the blockchain as a kind of orchestrator, not only for the production of these structures, but also to verify knowledge and create essentially a decentralized network between fabricators and validators on this. So we kind of have come up with an idea of how people could actually use the network. I won't go too much into it, right? There is also really published how interplanetary file system and smart contract work. But the main idea here is that we can actually, we have essentially been able to connect a 3D printer with the blockchain. And we're now moving ahead in launching the network in the next month or so. And this is a Raspberry Pi running a blockchain node and connecting. And right now we have 4 universities on board, which is the one you see, no, 5, sorry. The one you see here. And also ArchiDAO will participate in the whole kind of idea, essentially because a lot of the members of the scientific network are also members of the DAO. And we are kind of moving forward with this. The 2 research questions we're trying to solve, right, is how do we decentralize the data infrastructure for the scientific and engineering process to develop towards global standards and regulations for additive manufacturing, 3D printing and architecture? And what kind of token engineering and economics should we apply to the decentralized physical infrastructure of 3D printing, right? We have some ideas initially, we've published some of them, but not yet with any kind of, I would say, serious validation. So we need to test them and test them rigorously. I'll pause here.